Welcome back, students. Today is the session 23 of NEET Physics and the chapter is Rotational Motion. This is the question which I have taken from one of my test series which I normally take for my offline classes. And the question is, there are 4 solid spheres placed at the corners of a square of side 4 centimeter. The diameter of each sphere is root 5 centimeter and their mass is its mass is 0.5 kg. That is, the mass of each sphere is 0.5 kg. The moment of inertia of the system about the diagonal of the square is given as n into 10 to the power minus 4 kg meter square. So we have to find the value of n. So there are 4 options here, 8, 9, 10, 11. So we have to find the correct one. So in order to understand this question, I will be just drawing a small figure here. So this is a small figure here. This is a square of 4 centimeter side. This side, this is a square. It's say ABCD. And the 4 spheres are placed at the corners of these at the corners of this square. So this is, let us say, the 4 corners are A, B, C, D, and the side of each, the length of each side of this square is 4 centimeter, and the diameter of this sphere is root 5 centimeter. So we can say that the radius of this sphere, that is this is the radius. The radius of this sphere will be equal to root 5 upon 2 centimeter. The length of this square is 4 centimeter. The radius of each of these 4 sphere is root 5 divided by 2 centimeter. They are placed at the 4 corners of a square, okay, whose length is 4 centimeter. And now we have to find the moment of inertia of this entire system about the diagonal of this square. So there are 2 diagonals. This is one diagonal and this is another diagonal. This is the point. This is the point of intersection of this diagonal, which I am, and this point of intersection of this diagonal is O. I mean, I am depicting this point of intersection as O. Now, since these are the 2 diagonals, so this OA will be equal to OC, and this will be equal to OB, and this will be equal to OD, because these are the 2 diagonals of a square of sides 4 centimeter. So if the diagonals intersect at point O, then OA will be equal to OB, which will be equal to OC, which will be equal to OD. So I will be writing here as that OA will be equal to OB, which is equal to OC, and this is equal to OD. Now, we have to find the moment of inertia of this entire system about the diagonal of the square. So we can take any one diagonal. Let us say I am taking this diagonal BD. Now, the moment of inertia about this diagonal BD will be equal to the moment of inertia of this entire system about the diagonal AC. So, if you find the moment of inertia about this diagonal BD, or you can also find the moment of inertia about this diagonal AC. So in both the cases, the moment of inertia will be the same. That is, the total moment of inertia of this entire system, okay, will be the same. So in this case, I am just taking this diagonal BD, and so I will be finding the moment of inertia of this system about the diagonal BD. The moment of inertia of a solid sphere about an axis passing through the center of mass. The moment of inertia of a solid sphere, about an axis passing through the center of mass is given by the formula, that is 2 upon 5 mr square. where m is the mass of the sphere and r is the radius of the sphere. So it implies that is the moment of inertia. Let us say ICM. I'm writing it as ICM. That is the moment of inertia about of a solid sphere about an axis passing through the center of mass is given by 2 by 5 mr square, and this is the formula which you will be finding in the books. So this is equal to 2 by 5. Mass of one sphere is 0.5 kg. 0.5 kg into r square. So this is equal to 2 by 5, 0.5. The radius of this sphere, the radius of this solid sphere, that is the radius of each of the solid sphere is will be equal to root 5 by 2. Root 5 upon 2. Because the diameter is root 5. So radius will be equal to root 5 divided by 2. So this is equal to 2 divided by 5 into 5 by 10 into, and yeah, and now this is given in centimeter, and since we have to find the moment of inertia in kg meter square, so I will be converting this this radius in meters. So this will be equal to root 5 by 2 into 1 by 100, that is equal to into 100, that is equal to that, this will become equal to 200, because now this is in meters. So so this will be equal to 5 divided by 200 whole square. This 5 and 5 will cancel out, this and this will cancel out. So what I am getting is 1 by 200 whole square kg meter square. So the moment of inertia of any of these sphere about the axis which is passing through the center of mass is equal to 1 by 200 whole square kg meter square. So the total moment of inertia about the axis passing through the center of mass, the total moment of inertia, that is the moment of inertia of all these four spheres about the axis passing through the center of mass, will be equal to 1 by 200 whole square into 4, because there are 4 spheres, and this is the moment of inertia of an this is the moment of inertia about an axis passing through the center of mass of one sphere. So there are 4 spheres, so this will be equal to 4 divided by 200 whole square kg meter square. Okay, now so I would be writing this this value here right now for reference now. So this will be equal to, that is the total moment of inertia of all the spheres about the axis passing through the center of mass. This is equal to 4 divided by 200 kg meter square. Passing through the center, the total moment of inertia of all the spheres about the axis passing through the center of mass will be equal to 4 divided by 200 whole square kg meter square. Now we will be using the parallel axis theorem in order to find the moment of inertia of this this system about this diagonal BD. Now as per the parallel axis theorem, the total moment of inertia is equal to the moment of inertia about an axis passing through the center of mass plus md square, where d is the perpendicular distance between the axis of rotation and the axis which is passing through the center of mass. D is the perpendicular distance between the axis of rotation. Now in this case, since I have taken since I will be finding the moment of inertia about this diagonal, that is BD, so the D will be equal to the perpendicular distance between this diagonal, that is the diagonal BD, because this is the diagonal about which this system will be rotating. So this is going to become the axis of rotation. BD will be the axis of rotation, and this let us this line which I have made, this is a dotted line which I have made, which is parallel to this axis of rotation, and this line is passing through the center of mass. So D will be equal to it is the perpendicular distance between the axis passing through the this center of mass and the axis of rotation. So D, so now we have to find the value of this D now. This is D. So D is basically what? This is equal to OC. So we have to find the value of OC. Now, how we can find? We can use the Pythagoras theorem. We will consider triangle ADC. So in the triangle ADC, AD square plus DC square will be equal to AC square. So this is equal to 16, DC will be equal to 16, and this is equal to AC square. So it implies that AC is equal to root 32, that is 16 into plus 16 32, or we can say that it is equal to 16 into 2, which is equal to 4 root 2. Or we can say, now since these two diagonals are intersecting at this point O, therefore OA will be equal to OB, will be equal to OC, and this will be and OC which will be equal to OD. That is, OA will be equal to OB is equal to OC, which is equal to OD. I have written it here. OA is equal to OB is equal to OC is equal to OD. So now AC is equal to 4 root 2. So it means that OC kya hoga? It will be half of this. That is equal to 2 root 2 centimeter. Or it can, if in terms of this is in centimeters. So in terms of meter, it will be equal to 2 root 2 divided by 100 meter. Okay. So the value of OC will be equal to 2 root 2 divided by 100 meter. Now I have to find the value of md square in all these cases. In the case of sphere A, in the case of sphere B, in the case of sphere C, and in the case of sphere D. Now D is the perpendicular distance between the axis of rotation, that is in this case it is BD, and the axis which is passing to the center of mass. So for the sphere C and A, D is equal to 2 root 2 divided by 100 meter. For sphere that is B and D, D क्या होगा? D will be equal to 0. Why? Because for the sphere B and D, the axis of rotation, this is the axis of rotation, is also the axis which is passing through the center of mass. So for the sphere B and D, the axis of rotation is also the axis which is passing through their center of mass. So in that case, that is for the sphere B and D, D will be equal to 0. So now we have to simply find the value of md square. Md square is equal to, m is given as 0.5 kg and d is equal to, that is for the sphere C and A. This will be equal to 2 root 2 divided by 100 whole square. So md square is equal to, which is equal to 5 by 10 into 2 to the 4, 8 by 100 square. So this is equal to 40, that is equal to 4 divided by 100 square kg meter square. So here I will write the value of this md square. md square is equal to 4 divided by 100 whole square kg meter square. So now we have to find the moment of inertia of this entire system about this axis, that is about this diagonal BD. Now the total moment of inertia, as we will be using this parallel axis theorem, that is the total moment of inertia is equal to the moment of inertia about an axis passing to the center of mass plus md square. So we have to calculate the moment of inertia individually for all these 4 spheres, and then we will be summing it up. So the moment of inertia, let us say I, A, that is the moment of inertia for the sphere A will be equal to, that is the moment of inertia of this sphere about an axis passing through the center of mass, which is equal to, this was equal to, this is the total moment of inertia of all the spheres passing to the about the axis passing to the center of mass. So this was the moment of inertia of all these 4 this sphere. So for one it will be equal to 1 by 200 whole square plus md square. Now here this is the value of d, distance between the axis of rotation and the axis passing to the center of mass, and we have found the value of this plus md square. So we have already found the value of md square, which is equal to 4 by this 100 square, that is equal to plus 4 by 100 whole square. This is the moment of inertia, and this is the entire kg meter square. Similarly, the moment of inertia of the sphere C, this one, this will be also the same, that is 1 by 200 whole square plus, this is not 4, this is 1, sorry, 1. This is the moment of inertia of all the 4 spheres about an axis passing to the center of mass. So for one sphere it was equal to 1. So 1 divided by 200. So this is, sorry, this is okay, and here it was, here it was 4, okay, fine. So this is equal to, so for similarly for this sphere C also, this will be the total moment of inertia about this diagonal BD will be equal to ICM. ICM is equal to 1 by 200 whole square plus md square. Md square is equal to 4 by 100 whole square kg meter square. Similarly, ID will be equal to IB, and this will be equal to, now ICM plus md square, but in this case of sphere B and D, the value of D is equal to 0. So it will be equal to only the moment of inertia of this sphere, that is the sphere D and the B, will be equal to the moment of inertia about an axis passing through the center of mass. So this is equal to 1 by 200 whole square kg meter square. Now we will be summing up the this individual moment of inertia in order to get the total value of moment of inertia about the this diagonal BD. So the total moment of inertia of this entire system about about the diagonal BD will be equal to IA plus IC plus IB plus ID. This is the total moment of inertia of the sphere A. This is the moment of inertia of the total moment of inertia of the sphere C. This is the total moment of inertia of the sphere B and D also. So the total, how much it will be? This 1 by 200 square, this plus this will be equal to, if I add it up, that will be equal to 4 divided by 200 whole square, and this will be equal to 4 into, this will be this plus this will be equal to 4 into 8 divided by 100 whole square. So the total moment of inertia will be equal to, I will just take the LCM. Sorry, I have to now write this moment of inertia in this form, that is n into 10 to the power minus 4. So what I will do is, I will just take out this 100 square as common. So 100 square will be common. So this will be equal to 4. This is equal to 2 into 100. So 2 into 100 square means 2 into 100, that is, see, this is 2 into 100, that is 4 divided by 2 into 100 whole square. So what I have done is, I have taken this 100 square common. So if I just take this 100 square, 1 by 100 square as common, then I will be getting as 4 divided by 4, which is equal to 1. Plus, if I have taken 1 by 100 square as common, so this will be equal to 8. So this will be equal to 9 divided by 10 to the power 4. Or we can say that the total moment of inertia of the about BD, the total moment of inertia of this system of 4 squares about this diagonal BD will be equal to 9 into 10 to the power minus 4 kg meter square. This was in kg meter square. So which is the, so if I compare this with this, then the value of n is equal to 9. Okay? So our correct answer is the option B, that is 9. So here in this question, the most important thing was that you have to, first of all, you have to use the parallel axis theorem, where the parallel axis theorem says that I is equal to ICM plus MD square. So in this, so if you are using this theorem, then first of all you have to find the moment of inertia of each of these spheres about an axis passing through their center of mass, and then you have to find the value of MD square in each case. The value of MD square for this sphere B and D was equal to 0, because the value of this D was equal to 0, and the value of MD square for the sphere A and C, that was equal to how much? That was equal to 0.5 into R was equal to, sorry, D was equal to 2 root 2 divided by 100. Root 2 divided by 100 whole square, and this was in kg meter square. So the value of MD square for this sphere A and C was equal to this. So we have calculated this value, and for this is sphere A and C, and for this sphere B and D, the value of MD square was equal to 0 because D was equal to 0. And then we have added up the moment of inertia of all these four spheres in order to get the total moment of inertia about the diagonal BD. So thank you very much for joining this session, and I hope you have understood the way I have tried to explain it here. And my contact number is I'm writing here my contact number, which is equal to 9911079547. So in case of any queries or if you want to clear any doubts, I am always available on this number. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is the rotational motion. So the next session, that is the session number 24, will be uploaded maybe in a couple of days from now. So bye till then.